Hi everyone, I'm Yuval Fernbach, I'm co-founder and CTO at Qwak. And today I'm going to talk about 5 major challenges, maybe more, let's see, about deploying models in production, or basically how to productionize your models. So in this session itself, we'll talk about multiple topics. We'll start with production ML. Why is it so complicated? Why I'm going to talk about it, and why so many companies, it takes so much time to actually deliver to production. I'll talk a bit about production-first approach, at least my advices of how to eventually productionize faster and make sure that your models are actually affecting your product. We'll talk about building models, or basically building versus training, what things I at least think are missing from just training models. And then we'll move more to production, to some challenges in that area, how to serve models, how to manage models that are already deployed, how to replace models, and I'll save some time at the end for some questions. So let's start with production ML, why is it so complicated? So I believe there are a few different reasons why it's so complicated. One of them is that to productionize models, there are actually multiple stakeholders involved. So you have the data scientist that actually writes the model and train it. You have a data engineer, in many cases, that creates the data, both for training and in many cases, also someone needs to create the data for inference. So in many cases, they have a data source, a raw data source. The data scientist creates data from the raw data source, creates features for training, but then for inference, the same features need to be created directly from the backend. So you have this stakeholder. You have DevOps to manage the infrastructure of models, or MLOps in many cases. You have software engineers that need to integrate between the backend and the model. So there are so many different stakeholders, and this process in many cases takes time. I've seen cases where this process took months just to actually deliver the first model to production. I didn't talk about it, but before Qwak, I was an ML specialist at Amazon Web Services, and before that, I was the CTO of Mamram, the IT department of the IDF. So I've seen it, AWS, for example, many cases of companies struggling to deliver models to production. And what I'm trying to aim in this session and what we're doing in Qwak is helping companies to eventually achieve that in a faster way and streamline a process that allow the data scientists to iterate faster, to build directly to production. And this is the topic that I'm going to talk about today. So eventually the goal is to create a single process that takes a model and create a production model. Create a model that is built properly, that is deployed, that you save and track all its data, that you create and manage all its features, and eventually that evolves over time. So the first topic that I want to talk about is traditional build system and what happens in ML. So for example, when I'm writing a traditional code, let's say I have a Java code, and I'm building a new version of that code. What I will usually do is not just push this code to production, right? Usually I have a build system that will take this code. First of all, it will manage the versions of this code. Second, it will check the code quality. It will compile the code. I will probably run tests, unit tests, integration tests, end-to-end tests. I will install the dependencies, and only then I will create an immutable object that is versioned and is saved in any kind of artifactory, any kind of storage. What happens in many cases in models is that companies just train models. So in many cases, and that's a pattern that I've seen in many companies, is data scientists have, let's say, a notebook, an IDE, maybe even a fleet of GPU instances that they use to train a model. Eventually, they save this trained model artifact. Let's say it's a pickle or any other format of file in a storage. And when they want to deploy this model, they take this pickle or any other object and load it into the backend. So this build process actually misses so many parts that we use for traditional software to make sure that the software is built correctly. And what I'm recommending to do is to create an ML build system, a build system that allows you to build models in a way that is more production grade. And what I will advise you to do in this build system is things like, first of all, dependency installation. So models are usually written in Python. That's at least the current standard. And Python objects are Python dependencies are saved in PyPy repository, usually, at least the public dependencies. And in many cases, I've seen dependencies can be deleted from PyPy, for example. So you need to make sure that the dependencies are installed during a build, and eventually when you deploy a model, when you run inference on it, you don't reinstall this dependency. Second is model training. So you still need to run the model training, but you also want to have the ability to reproduce this training. So you probably need to save things like the metrics and the parameters that were used for specific model training, the code that was used for this training, the data set maybe that was used for this training. So it's not just running the training, it's saving all this metadata that connects to the specific training. Third is model evaluation. So that's something that data scientists usually do. Usually they do, and probably some of you are doing it, save a data set to evaluate the model and make sure that the metrics are as you expect. But you want to save this metric as well. You want to make sure that you understand what was this specific version. Fourth is model testing. So model testing is not just a data science thing. So if you build a model to production, this model have probably a function that run an inference on this model. You want to test this model, this function. In many cases, in this function, you have even other functions like data pre-processing or data enrichment or any other kind of process in the function. So all those things need to be tested. And you want to create a system that allows you to create unit tests, to create integration tests, to make sure that the new version actually works. When you build this new version, it won't eventually in production break down. So that's functional and integration test. And only if all that created, you want to create an artifact that is immutable. So this artifact should have all the dependencies already in it. It should have the trained model in it. This artifact should not have any moving parts during deployment of models. You want to validate that the artifact actually works, and of course, version it. So that's, as we see it in Qwak, a build system that is built for machine learning and make sure that models and new versions are built in the right way. And if I'm going back to the topic of production first approach, for example, doing that is not just a phase that you need to do at the end of the process. So in many cases, what I've seen is data scientists working on an IDE or a Jupyter notebook. They create new versions, they iterate on a model. And then after 6 months, they start to run the process of productionizing this model. So after 6 months, they take this artifact, they start talking with the data engineers, they start talking with the software engineers, they start building these things, and then it takes a few more months just to deploy this model. So what I usually recommend is to start this process at the beginning, even without a model, even only with a simple function, just a predict function, something that looks pretty much the same as the production environment, make sure that the process works as expected, and then build and iterate more and more on this version to make sure that this process eventually will not delay you in your process of productionizing this model and integrating with the backend. So a few examples of how we recommend, how we implemented that at Qwak. Not just the platform itself, more about structures and how you can, in a company, achieve that and build more and more models and make sure that eventually over time, those things will not break. So first of all, and that's what you see at the left side, is structure. We believe that when you create models, by the way, the same way as where you create traditional let's software, you need to have a structure, a way for, first of all, a new data scientist to understand how this model looks like, and also a way for a CI system to understand how models are built, and then automate this process of building version, deploying those versions. So for example, and this is a really simplified example of a structure, you can see that in each one of the models, I have a main folder and a test folder. The main folder have, for example, the requirements file in it. It can be a Kunda format, it can be a poetry one, it can be a requirements text, it doesn't really matter. It has a model py file, so let's say this is the model or the code where it imports from other Python files. And there's also a test folder. So in the test folder, you can create different tests, unit tests, integration tests. You can use different tools to actually run the test, for example, PyTest or others, to make sure that the model actually works as expected. So once you have this structure, it's easier to iterate between models, to create new models, and to onboard new data scientists to the same project or new projects. So this is the first thing. The second, and you can see that in the model itself, is to create a structure of how, not the model, not the code of the model itself, but how this model is wrapped, where the training actually happens or the build process is happening, and where the prediction is happening. So for example, the way we do that in Qwak is, in this class we have 4 different functions, and of course this is the mandatory ones or the ones that are part of the class, but you can create any internal data processing, etc. function that you want. And in these functions, there are a few ways to work. So first of all, the build function. This is the process that I want to run during a CI. So in here, I can write any code that I want. I can train a model. I can load the pre-trained model. I can even, I don't know, create a variable that I will need afterwards for the deployment. But this is what happens during a build. This is the part that I want to eventually serialize and make sure that is ready for me during prediction. Second function that you see is the schema. So something that I've seen that company in many cases wants is a way to show the world what this model expects to get, which features this model expects to get. Basically, the way to pretty much as any kind of, for API, you have Swagger formats, etc., a way to show your consumers what this expect to get. And the third function is the predict function. So in this function, you can write the actual inference code. And eventually using a structure, and again, it doesn't really matter what this structure looks like, but using a structure allow you to automate all this process and scale the number of models that you have in the company. I've talked a bit about tests, but this is an example of, for example, a function that gets a data frame, run an inference on that data frame, and just make sure that it gets the prediction that it expects. In this case, just making sure that it gets a prediction. But a way for you to create, in this case, it's not really a unit test, it's, let's say, some kind of an end-to-end test. So any processing that happens in the predict function will be tested. If you run any kind of feature engineering, if you run any kind of feature extraction, it will be tested and not just a function. It will test the whole process end-to-end. So a few things to consider when you create a build system. So first of all, I talked about it, but build immutable artifacts. Artifacts should not have any moving parts. It should have all the dependencies installed. It should have the trained model or loaded pre-trained model already in it. Second is save these artifacts in a place where you can actually find them afterwards. And actually, the third one is tag for reproducibility. Tag all the metadata. Tag the metrics, the parameters, the code, the data set even. Things that you'll be able to use afterwards to understand what happened in a specific training, what happened in a specific build, and even compare between different versions. Fourth is integrate to ICI system. So once you have a structure, once you have a way that every model looks like, and you have a process that you can use, you can then integrate that process to a CI system, make sure that with any kind of change in the code and merge to main, for example, this process will run and I will have a new version of this model. And fourth, and this is actually one a point that sounds like not as meaningful as the others, but actually really meaningful, is validate the artifact that you create. Creating an artifact in many cases is not enough. You want to make sure that this artifact works, actually can be started. The Docker doesn't, for example, if it's a Docker artifact, it doesn't crash. It works as expected. So in the day that you want to deploy it, it will work and not break at that time. So I have 5 more minutes. I will talk about a bit about model serving, some challenges over there, and some advanced topics in that area, and I will try to save some time for your questions. So regarding model serving challenges, and this is the next part. So once I created versions, I created builds, I created versions of models, you need to think ahead that these models can be used in multiple different scenarios. In many cases, models are used as batch execution. So cases like churn, LTV, any type of marketing models, those are usually models that are executed in a scheduled way, and then this data is used during that time period. But in many cases, models are needed to be an API, a real-time API. So for example, from recommendation engines to fraud detection, in many cases you want to have an API, and you need to think ahead of creating a mechanism that allows you to deploy models both for batch, for real-time, and even in the more advanced cases is streaming. So models, for example, that consume from a Kafka topic and then produce to another topic. So you'll be able to actually integrate to more and more use cases and backend solutions in your platform. Second thing that you need to think of is how you test new version, how to manage these models. So things like, for example, how to replicate data from one model to another and evaluate how a model actually functions, or how to gradually roll out a model. How to run A/B testing. So this is something that we're seeing more and more. Companies create new versions and want to actually run A/B tests on that version. Want to make sure that the version works as expected. Want to look at the metrics of this version before they deploy it for all of their customers to make sure that they are not will not just have fault answers. And even topics that we're seeing more and more in many cases is companies want to create multiple models, not just one big model for all of their customers, but create multiple models per each one of their customers, then shift traffic to each one of those models based on different features. So this is even more advanced, but those are things that you need to think ahead. Last topic that I want to talk about, and regarding the last one is a bit more about A/B testing, but because this is a topic that we are seeing more and more, and it's not just moving traffic between one model to another. So the thing with models, and that's a bit more complicated than, for example, A/B testing UI, is that models metrics is something that is quite complicated to actually calculate. And there are different types of metrics that you calculate. There are metrics that are based, for example, on the data that goes through the model or the output of the model. Things like, for example, distribution of the output or features. But you can also calculate the actual metrics. So for example, Toloka just talked about annotators and the ability to create data sets. So for example, you can add like a feedback loop, create a feedback loop, add a human in the loop to actually label some of the predictions and try to understand what is the actual metric of a model. And think of a case where you not just shift traffic between models, let's say the VIP customers to model B and all of the rest of the customers to model A, or beta customers to model B, but you also want to understand what are the metrics of model. So if, for example, you'll automatically save all the data that goes through a model. So you'll be able to automatically see the distribution and create reports. And in addition to that, you'll close the feedback loop, send back feedbacks, what are the actuals of models, and create the metric of the model, let's say accuracy. You'll be able to see if a new version actually works as expected, and based on that, decide how to roll out a new version. So those are things that you need to think of, you need to build to actually have these mechanisms This is something that we invested quite a lot of time in Qwak to make sure that companies can actually achieve using our product, and we'll be able to talk about it even more. So in this session, I talked about many different topics, but if anyone have any question that want me to answer right now, then feel free.